Example 2. A beam of light passes undeflected through two parallel horizontal plates 1.5 cm apart, having a PD of 3000 volts when a perpendicular magnetic field of 10 raised to the power minus 2 Tesla is applied, and in magnetic field alone the beam is bent into a curve of radius 2 meters. Calculate the charge mass ratio of the ion. Solution. Since the beam is undeflected, the force due to magnetic field equals to the force due to electric field. BEV equals to EV. Therefore, V is equals to E over B. V is equals to 3000 all over 1.5 times 10 raised to the power minus 2 times 10 raised to the power minus 2, which is equals to 2 times 10 raised to the power 7 meters per second. In the magnetic field alone, BEV is equal to mv squared over r. Therefore, E over m is equal to V over RB. E over m is equal to 2 times 10 raised to the power 7 all over 2 times 10 raised to the power minus 2, which is equal to 10 raised to the power 9 coulomb per kilogram. Electromagnetic field. Transformer. In a transformer, an alternating current flows through the primary coil, giving rise to change of flux around the primary and secondary coil, giving rise to an induced EMF in the coil. Transformers set steps voltage up or down according to its turn ratio. From energy conservation, we have that transformer formula: secondary voltage ES over primary voltage EP equals to secondary turns NS over primary turns NP, or ES over EP equals to NS over NP equals to IS over IP. The above equation holds where the transformer is assumed to be 100% efficiency. Example 1. If the efficiency of the transformer is 80% and the current in the secondary is 10A, calculate the current in the 240 volt supply. Solution. Let LP be the current in 240 volt supply. Power in the circuit equals to IV. Power in the primary equals to IP times 240 watts. Power in the secondary equals to 10 times 240 watts. Efficiency is equals to output power over input power. That is 80%, which equals to 10 times 24 all over IP times 240, or 80 over 100 is equals to 10 times 24 all over IP times 240. 80 times IP times 240 equals to 100 times 10 times 240. IP is equals to 100 times 24 times 100 all over 80 times 240, which will give us 1.25 amp. Example 2. A transformer has 300 tons of wire in the primary coil and 30 tons in the secondary coil. If the input voltage is 100 volts, find the output voltage. Solution. Number of turns in primary coil MP equals to 300 turns. Number of turns in secondary equals to 30 turns. Let EMF of secondary be E, be X. EMF of primary EP equals to 100 volts. From ES over EP equals to NS over MP. 30 over 300 is equals to X over 100. 300S is equals to 30 times 100. X is equals to 30 times 100 over 300, which is equals to 10 volts. The output voltage is equals to 10 volts. Example 3. A transformer 5,500 tons in each primary is used between a 240 volts AC supply. a 120 volt kettle. Calculate the number of turns in secondary. Solution. Use the formula EX over EP equals to NS over NP, but NS equal to number of turns in secondary, which is unknown. NP is equal to number of turns in primary, which is 5,500 turns. ES equals to EMF of secondary, which is 120 volts. EP equals to EMF of the primary, which equals to 240 volts. Therefore, NS over 5,500 equals to 120 over 240. Making NS the subject of the formula, we have 5,500 times 120 all over 240, which will give us 2,750 tons. Example 4. A transformer is used to operate a 12 volt to 24 watt lamp for 240 volt AC mains. A. What turn ratio is required? B. If the efficiency is 75%, calculate the power losses. Solution. A. Turn ratio equals to turns in secondary over turns in primary, which is equals to 12 volts over 240 volts, which is equals to 1 over 20. B. Efficiency equals to power in the secondary over power in the primary times 100%, which is equals to 75%. That is 24 watts over P equals to 75 over 100, which equals to 3 over 4. Energy losses within the transformer is equals to 32 minus 24, which is equals to 8 watts. Example 6. A transformer has a primary coil with 500 turns. Calculate the output voltage and the turns ratio when the voltage input to the primary is 120 volts. Solution. EMF in secondary, EF over EMF in primary, EP equals to number of turns in secondary, NS over number of turns in primary, NP. ES over EP equals to NS over NP. ES over 120 equals to 2,500 over 500. Making ES the subject of the formula, we have 2,500 times 120 all over 500, which equals to 600 volts. Solution. Turn ratio equals to EMF in primary over EMF in secondary, which equals to 120 over 600, which equals to 1 over 5 or 1.5. 4.5 Simple AC circuit. Introduction. An alternative current AC is a current which varies periodically. The current circuit in which an alternating current flows is called an alternating circuit. E equals to EO sin W omega T. LO equals to LM sin W omega T. Figure 434a, a graph of V against T relationship, and figure B is a graph of I against time X relationship. A. The EMF varies sinusoidally with time in a rotating coil, which is given by capital E equals to EO sin 2 pi ft is equals to EO sin omega T, where capital E, EO equals to EM are the instantaneous and maximum peak value of capital E or the amplitude respectively. Omega T or 2 pi ft is equals to phase angle.